In this video, we're going to look at analog inputs. Analog inputs can have a value other than 1 or 0. They can have a whole range of values. In a real-world microcontroller circuit, an analog sensor would be a light sensor, a heat sensor, or a rotary control. We're going to start off with a furnace simulation. The furnace is going to be connected to output 0. When it goes high, the furnace turns on. The thermostat or analog sensor for the furnace is going to be connected to input 4. Here we have the input slider. The settings for the pickaxe chip should be the same as in the previous video about digital inputs. Let's go up and take a quick look to make sure that yours are the same as mine. I'll look at select pick type. We're using a pickaxe 08M with outputs on 0, 1, and 2 and inputs on 3 and 4. That's the second last selection in my version of logicator. We're going to start building this program with the compare command that's found in the variables grouping in the command list. I'll drag the compare command 2 cells below the start command, and we'll double click on it. And here we get this dialog box, and it says set the expression to compare. This expression is similar to the input pattern on the decision box. If the conditions in the program match this expression, the program will leave the compare command on the yes path. Otherwise, the program will follow the no path. The first drop-down window contains a list of analog inputs and variables. We'll choose A4 or analog input 4. The second drop-down box contains a list of comparison operators. We're going to choose less than. And the last drop-down box contains a list of analog inputs, variables, and numbers. We'll choose 20 for 20 degrees Celsius. Now I'll give it a label here. I'll say temperature less than 20, question mark, and we'll click OK. And there's our compare cell. Before we add the rest of the commands, let's test the compare cell with the analog panel. I'll bring it out by clicking on it, and we'll go to input number 4, and I'll set the temperature sensor to 19 degrees. So that's below the 20 that we have here. Then I'll open this by double clicking on it, and the expression says, is the sensor less than 20? Well, 19 is less than 20, so let's test it. We should get a true. And that's right, that's true. Now if I go and try to slide this, I'll get nowhere. I actually have to close this first. So I'll set the sensor value higher than 20. I'll make this one 21, and we'll open this again. And now we're saying, is 21 less than 20? Well, no, it's not. So we'll get a false. So this thing is working as we expected it. I've added 2 commands here. One to turn the furnace on, and one to turn the furnace off. Let's put a comment on this command. I'll type in here, furnace on. It's a good idea to put some comments on your program. That way, if you have to come back at a later date, you'll know what all the commands are for. So I'll click OK, and we have a little comment here, furnace on. Now I'll start adding the program flow lines. The first thing the program does is to check the heat sensor. The first line to leave the compare command will be the yes line. So I want it to go to furnace on. If the temperature is less than 20, if that's true, yes, we want the furnace to turn on. After the furnace turns on, we want to check and see what the temperature is to know what time it is to turn the furnace off. The second line to leave the compare will be the no. So I'll go and I'll route that to the furnace off. If the temperature is not less than 20, then we need to turn the furnace off. It's too warm. And once the furnace is off, we want to go back and check the sensor again to find out what time it is to turn the furnace on. Before we run the simulation, I'll bring out my analog panel and put it to the left here, and underneath it I'll put my digital panel. So here's our temperature sensor on A4, and here's our furnace motor on output 0. I'll go to simulate and I'll say run, and you can see the flow of the program. It's coming through the yes loop all the time because the temperature at 0 is definitely less than 20 and the furnace stays on. Now as I gradually increase the furnaces on and the house will be getting warmer and warmer, eventually the temperature goes past 20. We're at 21, and now it's going to go through the no condition. 21 is not less than 20. We get a no, and the furnace stays off. If the furnace stays off long enough, then the temperature will drop below 20, and now we are going into the yes loop, and the furnace is on again. So we've built a nice little temperature controller.